Hello, and welcome to week 5 of Intro to Algebra. This week we're going to talk about ratios and proportions. We're going to start talking with ratios first. Ratios is when we have a comparison of two numbers by division. So examples of ratios could be if I said that we had 10 chocolates to 6 candies. We could write this as 10 over 6, or we could write this as 10:6, which is read as 10 to 6. Another example is if I talked about us having 18 red marbles, 9 violet marbles, and 14 yellow marbles. If I wanted you to create a ratio and put it into simplest form, I would have you start just like I did in example 1. If I wanted you to do red to violet, I would have you start by taking the 18 red to the 9 violet. If I wanted you to take red to yellow, we would take the 18 red to the 14 yellow. However, neither of these examples yet are in simplest form. What I mean by simplest form is we need to pull out any common factors and simplify these. Both 10 and 6 in example 1 are even numbers, meaning if I needed to go through and simplify them, I could divide each of them by 2. 10 divided by 2 is 5, and 6 divided by 2 is 3. So in simplest form, I would have 5 over 3, or 5 to 3. In these examples down here with the marbles, if I was comparing the red to the violet, both 18 and 9 are divisible by 9. So if I divided both of them by 9 to simplify it, 18 divided by 9 is 2, and 9 divided by 9 is 1. The ratio I would be looking for in simplest form is 2 to 1. Whereas red to yellow, 18 and 14 are both even, so I would divide both of them by 2, leaving me with a new ratio of 9 to 7. There are no common factors, so I can't pull anything out or simplify this anymore. So this would be the ratio I was looking for in simplest form. We're now going to talk about are ratios equivalent? How we test if ratios are equivalent is we have to set them together and then cross multiply or find what's called the cross product. So in this case, if I'm testing if 6/8 and 12/16 are equivalent, I'm going to start by setting them equal to one another. When we say find the cross product or cross multiply, I'm going to create a cross inside of here, or an X, and multiply the numbers that are now attached. So I would have 6 times 16, and I want to test, is that equal to 8 times 12? If we pull out our calculators, 6 times 16 gives us 96, and 8 times 12 also gives us 96. Because this is true, these are equivalent. In example 4, we have another set of equations, another set of these fractions that we need to test if they are equivalent. So once again, I'm going to set them equal to one another. So I'm going to test, is 7 divided by 14 equal to 9 over 16? I'm going to, once again, cross multiply to find our cross products. I'm now going to have to do 7 times 16 and test and see, is it equal to 9 times 14? Well, 7 times 16 is 112. 9 times 14 is 126. Unfortunately, that is not true. That is false. When this happens and you get two equations that do not set themselves equal to one another and it is false, These are not equivalent. The next thing we're going to look at is unit rates. A unit rate is when the denominator is equal to 1. So in example 5, which is much like things that we saw in unit 4, if I said that we drove 180 miles for 3 hours, and I want to find my rate of speed, I'm going to have to create a ratio. My ratio is I went 180 miles over a time period of 3 hours. Our denominator right now is 3. It is not 1, so we must divide. When we divide, we're going to get our unit rate. Our unit rate when we do 180 divided by 3 is going to give us 60 miles per hour. That means for every 60 miles that we drive, we're going to be going for 1 hour at a time. 60 miles per every hour. So 60 miles per 1 hour. Let's now flip over to the backside and talk about why we need to use unit rates. The reason we have to use unit rates is it allows us to make comparisons. If everything we do is all using the same rate, I then can go through and actually just say, hey, this one's faster, this one is not. We'll do several examples and projects in class where we can compare speeds or rates. One example of a rate that's not a speed is example 6, where if we say Taylor was paid $15 to babysit for just 3 hours, Ariel's paid $20 to babysit for 5 hours. We're talking 2 different amounts, but it's also over 2 different time periods. So we want to find the rate. We want to find how much each of them get paid per hour. So let's start with Taylor. Taylor gets paid $15 for 3 hours of time. Whereas Ariel gets paid $20, but Ariel does have to babysit for 5 hours. Again, the comparisons right now are not the same. So if I divide to find my unit rate, I'm actually going to find that Taylor gets $5 per hour. 15 divided by 3 gives us 5. So when we do 20 divided by 5, that's going to give us $4, meaning Ariel gets paid $4 per every hour that she babysits. So the question was, who gets paid better? 5 to 4, we're now talking not just dollar amounts, because if I talk dollar amounts, Ariel's looks better. She made $5 more. However, if I talk rates, Taylor actually gets paid more per hour. The next thing we want to talk about is proportions. Proportions is an equation that states that 2 ratios are equal. There are 2 kinds of examples that we're going to look at. We're going to look at an arithmetic and an algebraic rule. So up here, the arithmetic means that we actually have numbers that we're comparing. If you have 2 equal fractions or comparisons, that means, using cross multiplication, that I know 6 times 5 has to be equal to 3 times 10. In an arithmetic example, this is always true. The same goes for algebraic. I don't need numbers. If I know that these two fractions are equal to one another, I can still cross multiply. I can say, because these are equal, A times D has to be equal to B times C. That only works though when my denominators are not 0. You can never have a fraction when a denominator is 0. So we're going to add in that line when B does not equal 0 and D does not equal 0. And our last example of the day is example 7. The exchange rate for Mexican pesos to US dollars is 10.737. If I told you that you had 250 pesos and you're trying to convert it back to US dollars, we want to figure out how much US money you have. The very first thing that you want to do is you actually want to set up a proportion. So step 1, set up proportion. What that means is my conversion is I get 10.737 pesos for every single 1 US dollar. I know that I'm going to put P for pesos and the $ for dollars. I know that I have 250 pesos right now, but I'm going to use D because I don't know how many dollars I have. And I'm also going to put a note here that D equals dollars. The second step that you're going to do is you need to cross multiply and find your cross product. So when I cross multiply, I'm going to find that I have $10.737 equal to, well, 1 times anything is itself, so that's equal to 250. And the third step is to solve for the unknown. So here, if I have the equation that 10.737D is equal to 250, I'm going to have to divide. Divide both sides by that 10.737 so I can get my D, the dollar amount that we're looking for, alone. When we do that in our calculator, we're going to find that D equals, it's dollars, that's what we're searching for, $23 and about 28 cents. That means that 250 pesos equals $23.28 American dollars. We will continue going over this in class over the next week.